Welcome, class. It is Dr. Linder, and welcome. We're going to be talking about the overview of the neural system in this video. And in this first picture, I show Homer Simpson here. It's a little bit of a silly cartoon, and people look at it and go, well, he's got this big skull and this small little brain in here. Maybe he wasn't that intelligent. The reason why I put it up is just to kind of start a little dialogue with you in terms of um, just because you see a small brain, it doesn't mean lack of intelligence. Okay, if you think of computers way back when they first came out, computers were very, very large. They were big, they would overheat, they would have to keep them in air-conditioned rooms with lots of fans to cool them off. And now what we start to see is that computers are getting smaller and smaller and smaller, and yet they're getting faster and faster and faster. Okay, so keep that in mind. When we look at the neural system, it's important to understand that when we study it, we can look at it as two different parts. We can say the CNS, and then we can look at the PNS. The CNS stands for, what it stands for is central neural system. And then PNS stands for peripheral neural system. So we have a central neural system and a peripheral neural system. The central neural system is central. All it is the brain and the spinal cord, nothing else. Important to know, it's only the brain and the spinal cord. What makes up the CNS? The brain and the spinal cord, nothing else, no nerves. When we talk about the peripheral neural system, now it's everything in the periphery, everything that radiates or comes off of the brain and the spinal cord is considered peripheral. So brain is central nervous system, but the nerves that come off of the brain are referred to as cranial nerves. And I have a video, if I don't get to it in this lecture, I do have a video going over the 12 pairs of cranial nerves, the 12 pairs of cranial nerves. And you should know them by Roman numeral as well as their name. Okay, they're not written like cranial nerve 1, cranial nerve 2, cranial nerve 3. They're written like cranial nerve 1, cranial nerve 2, cranial nerve 3, cranial nerve 12. That's how they're written. Okay, and they all have different names. So nerves that come off of the brain are cranial nerves. Nerves that come off of the spinal cord are called spinal nerves. Okay, so what is this term ganglia? It's important to know what a ganglia is. So on this side here, I'm going to put the word nucleus. And on this side, we'll put the word ganglia, or sometimes ganglion. They're interchangeable, ganglia or ganglion. And what is a nucleus within the neural system, and what is a ganglia or ganglion within the neural system? I'm going to use abbreviations here. You can always play back this video. If you're not fast enough to get everything I'm saying, it's okay. But a nucleus is a group of nerve cell bodies within the central neural system. So what is a nucleus? A nucleus is a group of nerve cell bodies within the central neural system. Well, what is a ganglia? A ganglia is pretty much the same thing. It's a group of nerve cell bodies within the PNS, within the peripheral neural system. So this is like real estate, location, location, location. So if you have a group of nerve cell bodies within the central neural system, we're talking about nucleus. And if we're talking about a group of nerve cell bodies outside of the CNS or within the PNS, we're talking about a ganglia or a ganglion. Okay. Then we have an axon, and then we have a nerve. Okay. Actually, let's call this not axon. I want to call this tracks. Okay. And here we'll have nerve, nerve and tracks. So when we have a group of axons within the CNS, a group of axons within the CNS, we're talking about tracks. When we have a group of axons in the peripheral neural system, we're talking about nerves. Nerves. Okay. So just some general terminology. All right. So again, what is the CNS? Brain and spinal cord. What is the PNS? Cranial nerves, spinal nerves, ganglia. Okay. Everything that's considered outside of that is the PNS. Now, something else I want to point out to you is that we can have information that comes in to the spinal cord and goes up to the brain, okay, that goes upward in this direction, moving this way, going up, and we call that sensory information. That's sensory information. And because the information is going upward, we say that it ascends. And we also refer to that as afferent information. A-F-F-E-R-E-N-T, afferent information. And then the brain takes that information and it can send commands going down the spinal cord and out to your organs or out to your muscles. So because that information is going down and out, we say it's descending information. It's descending information, but it's motor information, motor, and efferent. They all pretty much mean the same thing. Sensory is information coming in, motor is information going out. Sensory information is ascending, it goes up. Motor information is descending as it goes down. Sensory is afferent, motor is efferent. Okay, and you're going to see these terms throughout neurology, so it's important to grasp some of those basics now. So again, the central neural system is the brain and the spinal cord, and the peripheral neural system refers to cranial nerves and spinal nerves. And the peripheral neural system is going to connect to your muscles, it's going to connect to your glands, and all of your receptors, all of your sensory receptors. So here up on the top, this is your central neural system. Remember, it's your brain and your spinal cord. And your brain and your spinal cord receives sensory input. So it's going to be bombarded with information coming from your soma, which means your body, like your muscles, okay, like your organs, special senses, your eyes, your ears, okay. When we think soma, we're thinking primarily muscles. Keep that in mind. That's what they're primarily focusing on. Muscles have lots of receptors in them, right? Because every time a muscle is contracting, your body needs to know how much tension there is, what is the position of it, is it being overly stretched? We want to avoid injuries. So we have all this sensory input coming in to the brain and the spinal cord, and then there has to be motor output going outward. going to the soma, going to your skeletal muscles, giving them commands how to contract, but also not just information going to the somatic neural system, not just going to the somatic neural system, but also the ANS. The ANS is an abbreviation for the autonomic neural system. Now, when we talk about autonomic, there's two main branches that I want you to focus on: sympathetic and parasympathetic. Sympathetic and parasympathetic. And for the most part, I think of sympathetic as the accelerator, and I think of parasympathetic as the brake. That's why I put the positive and the negative. Okay. Sympathetics, sympathetics tend to speed things up, like speeds up your heart rate when you're being chased. Parasympathetic, when that engage, it kind of slows things down. It keeps you calm, cool, and collected. Sympathetics are what we call your fight and flight response. So sympathetic is your fight and flight response, meaning you're being chased, you better run to get out of danger's way. That's flight, or you got to be ready to fight or flight response. So your heart's going to increase, your breathing is going to increase, your pupils are going to dilate. You know, you're under stress. That's your stress response. Parasympathetic is, hey, you're relaxing, you're listening to music, glass of red wine, digesting a meal, digestion. That's parasympathetic. Okay, so sympathetics and parasympathetics are going to your smooth muscle like we will learn in a week, blood vessels, where blood vessels have an internal layer. It has a smooth muscle layer, and then it has a third elastic layer. And what you learned in Anatomy and Physiology 1 when you covered tissues and you did muscle is that there's three types of muscle: the skeletal muscle, smooth muscle, and cardiac muscle. Smooth muscle is involuntary, you can't control it. Cardiac muscle, involuntary, you can't control it. The only type of muscle you can control is skeletal muscle. This is the only one that's voluntarily controlled. So when smooth muscle of your arteries relax and they dilate, this lumen opens up and blood pressure goes down. But under stress, under sympathetic stress, this muscle constricts and this lumen becomes much, much tighter and smaller and blood pressure goes up. Okay, so sympathetics and parasympathetics. So the somatic, when we think of the SNS, the somatic neural system, this is voluntary. You have conscious control over the motor neurons to your muscles, especially your skeletal muscles. Whereas the autonomic sounds like automatic, it's involuntary. This is going to involve motor neurons to your smooth muscle, to your cardiac muscle, and to your glands. And sympathetics are your fight and flight response. The sympathetics are your fight and flight response. The region of the spinal cord that you'll find your sympathetics is from T1 to L2. Because it's T1 to L2, it's called the thoracolumbar output because it's going from T1 to L2, thoracolumbar output or thoracolumbar outflow. The parasympathetic, on the other hand, this is called the craniosacral outflow or craniosacral output. So there's two divisions here, a cranial division and a sacral division. The sacral division is S2 to S4, and the cranial division are cranial nerves 3, 7, 9, and 10. 3, 7, 9, and 10. And when we study cranial nerves, we'll know that cranial nerve 3 is called the oculomotor nerve, and we'll know that cranial nerve 7 is the facial nerve, and then we'll know that cranial nerve 9 is called the glossopharyngeal nerve, And then we'll know that cranial nerve 10 is the vagal nerve or vagus nerve. So craniosacral outflow is cranial nerves 3, 7, 9, and 10, and sacral segments S2, 3, and 4, which help keep the feces off the floor. S2, 3, and 4 help keep the feces off the floor. If there's damage to that sacral region, people lose bowel control. Okay. Again, sympathetics is going to speed up your heart rate because it's sympathetics we think of as the accelerator, and the parasympathetic think of the brake, slowing down the heart rate. The only thing that the parasympathetic speeds up is going to be, think of digestion. And then sympathetics will slow down digestion. So they're opposites. Think of it this way. Grandma may tell you after feeding you lunch or dinner, don't go out and play. Because when you're digesting, that's a parasympathetic thing. When you're running around playing, that's a sympathetic thing. If you want to digest your food, you want to be relaxed in a parasympathetic state of mind. When you're running or playing or swimming, that's a sympathetic thing. Everything's revved up. That means that heart is being diverted to your muscles and not your digestive tract, which is where we want blood being diverted when you're digesting food, to the digestive tract. Okay. Also, when you're eating, you don't want to fight or argue with someone because you could lose your appetite because digestion is parasympathetic, fighting and arguing is sympathetic. So hopefully that kind of puts things into perspective. We'll take our first break. When we come back, we'll get into the neuron, but let's see if anyone has any questions for